I'm Danielle Jobe, like he mentioned. I work for VI Technologies, and today I'm going to talk to you guys about using the right tool for the job, which in this case will be integrating LabVIEW with Python and also JavaScript. I think I was very ambitious with what I wanted to talk about, so hopefully we can go over everything today. Hopefully there's enough time. I have a demo that I'm going to do live that maybe I can get. I know. We'll see if that works. And yeah, you know, got to do it somewhere. And also for that demo, I'm going to need volunteers. And if nobody volunteers, then I'll pick victims. So starting off, I'm going to talk about the giants that are female. My giant is my mom, who's also a technical woman and has always been a role model in that for me. She studied physics and electrical engineering in the 1970s, in which very few women did that then. So she was, one of 4 women in her whole department, which I think is pretty cool. A lot of prejudice back then that I never saw really growing up in physics, but she's been 38 years in the space and radiation business. When they send microelectronics into space, there's a lot of radiation in the environment, and she does testing on what will make the microelectronics fail and how to make rad hardware. So it's super, super rad. And she was the chair for the IEEE Nuclear Space Radiation Effects Conference and the first woman technical fellow at Boeing Space. She's just a brilliant and wonderful person. I think that she's the nicest person that any of you would ever meet. She's the nicest person I've ever met. She's super great. So yeah, she's my giant. So yeah, we're going to talk today about Python, LabVIEW, and JavaScript. I'm not going to teach you how to do anything in Python. I'm not going to teach you how to do anything in JavaScript. I'm just going to show you how to do it from the LabVIEW side, connecting to these guys. I have some demo code that you can check out later. That's going to show some of the Python and JavaScript if you want to see that too. So a brief overview of what I'm going to talk about. Start off with where does LabVIEW really shine and what's it best at? When is it the right tool for the job? And then when is it a good idea to use Python? How to do that from LabVIEW. And then we're going to switch gears a bit and talk about when does JavaScript take the lead and how to show that LabVIEW data that you may have acquired from a JavaScript web app. And then I'm going to show you that demo. I really want to make sure that I get to the demo because it was really fun to make. And so maybe someone can let me know when I have 15 minutes left. Cool, thanks, Darren. So I have little icons in the corner so you know what we're talking about if you zone out. So when is LabVIEW the right tool for the job? I think that it was born to do hardware communication. I don't think it was, I'm pretty sure, born to do hardware communication, mostly talking to the NI hardware, but there's so many great ways to natively talk to a lot of different hardware with a lot of different protocols, and if it's not native in LabVIEW, most of the time there's a toolkit for it. So it's easy to do, and it's what it's best at. I don't really like Verilog or VHDL because it's too low level for me. I don't have time for that. I like LabVIEW though, and I love FPGAs. So programming FPGAs in LabVIEW, to me that's freaking cool. I think also since LabVIEW is great at parallel processing and it's good with timing, it's great at the control system. You drop a loop and that's your logging, you have another loop, and that's your data acquisition. You have another loop, and that's showing your data in a user interface maybe. And and you can control all of those loops. You control all their lifetimes. You can control it all in LabVIEW very easily, especially if you have a really nice framework that you're using. So then why would we want to use Python? Well, there's a lot of libraries. A lot. I think LabVIEW Community is wonderful. It's one of my favorite things about LabVIEW. I like the language itself too, but it's very small, which is great because we have a nice sense of community like we all are seeing here. But we don't have as many tools at our disposal. There's just not as many libraries that are written. It's the reality of it. Python's open source, and there's a lot of tools that are available. So it's nice to be able to call it from within LabVIEW, utilize those things. Things like machine learning, big buzzword these days. A lot of people like it. I think it's pretty cool. It's not the right tool for every job, but for some jobs it does a really great job. And similarly, image processing. There's a lot of stuff that we've done in LabVIEW for image processing, and I think it also is super capable in it, especially with iMac stuff. But OpenCV is an open source Python toolkit library. It's in a lot of languages, but it's also in Python. And it's super powerful for image processing, and it has some machine learning algorithms that you can do built into it, which is really nice. And in my demo, I'm going to use OpenCV. A very practical reason that I've run into before, someone else already wrote the code that I needed in Python, and we already have internally. So even if you don't understand it, if it already does the job, you might as well use it instead of rewriting it in LabVIEW. So how do we do it? Are you guys convinced that sometimes it's useful? The easiest, or maybe the most basic way of doing it is to use the system exec VI. So you guys, is everybody familiar with this VI? Cool. So yeah, you just call command line stuff from LabVIEW. It's pretty simple. It's pretty easy to implement. It's pretty easy to test. So yeah, you just, anything that you would type in the command line, you can test it on the command line, you can test it in there, you just run it. It's not that hard to get set up. It ships with LabVIEW. Oh, and that's it. What are the drawbacks? Well, it's super slow. Every time you want to call Python through there, it's the slowest of every way that I've tried to connect to Python, by far, by an order of magnitude. You also don't have any ability to abort or have any insight into the execution. You can show the console and see some things if you're printing stuff during your Python script, but yeah, other than that, there's not a ton of insight. Also, there's no data type support. Everything is going in and out as a string, and you need to do all the conversion yourself, which, yeah, that's not that fun sometimes. Also, error reporting and error handling, similar. It's all a bunch of strings, and so you need to parse it all yourself. There's a little bit of error handling, but it's, yeah, from the system exec. So let's say, for example, we have a hello script, hello world script. It's in Python just printing hello world. In the command line, we just say Python hello world script.py hello world, assuming that we're in the working directory where the script is located, and we have the Python environmental variable set on our system. If you don't, then you need to type the whole path of your Python exe. So you just take literally what you put there and you put it in the command line. Simple, done. For a module, you can also call functions that are defined within modules on the command line. So if you have a function defined, say hello, that takes an input name, and it returns hello name, then you just say Python, you tell it -c, which says that you're going to run a command, and then you say import hello world as HW, so you're giving it an alias, and then you just say print hello world, say hello GDevCon, and it says hello GDevCon. Not that difficult. Same thing, just put it in the input for the command line, and it'll output hello GDevCon. Method 2. This is something that I played with a bit, and in my demo I'm using it. It's the nthought Python integration toolkit for LabVIEW. It's pretty easy to use and set up. It has a pretty clean API, which I'll show you in a minute. It has pretty good data type support. So depending on if you want to use different arrays and stuff, you're not converting everything from a string, which is great. And most of your LabVIEW normal data types are supported. It also has pretty good error handling, so you don't have to do it all yourself. And it also includes Canopy, which is a nice Python IDE that normally you have to pay for. So that's kind of nice. It also has pretty good package support, so if you want to install things like OpenCV and use that, that's nice because it integrates very well. It's also pretty fast. Of the methods that I tried, it was almost as fast as the fastest one. And on actually more complicated functions, I found that it was as fast. I thought it was kind of strange that on the simpler ones, it was not quite as fast, but the more complicated, it was faster. So, I don't know. Not sure why. But it's expensive. To me, that's expensive. Maybe not to you guys. But so it does cost money. They also do have, I think, discounts if you buy volume. So if you're using it for a large team, it won't be quite as much per seat. And it also doesn't work with the very latest version of Python, but I assume that they'll be constantly improving that and adding that feature. It also, every time you open, in the beginning you have to open a connection to your Python file, and it's very slow when it opens that connection. Every call to the function within the module is very fast, but opening the connection in the beginning is slow, so I recommend that if you're going to use it, you load it once in the beginning and then cache the reference and use it throughout your application. And it also has to be done for every Python module referenced. So if you're opening a lot of them, you have to cache a lot of references. And there's kind of limited documentation. There's stuff, but not as much as there could be, in my opinion. And I ran into some issues with data type conversion. So it does handle the data type conversions for you, but if you, for example, it uses NumPy arrays. It converts LabVIEW arrays to NumPy arrays, which is a data type in Python. If you're using NumPy, which is a particular, like science data processing package. Basically, it converts it to this particular type of array that's not the standard array type in Python, because Python uses something called lists, which is like an array, but it can have different data types, so it won't be all numbers. You could have number, string, Boolean, all in the same array, and that's a list. But NumPy arrays are not. So anyway, I'm not sure if that made sense, but you could run into some issues with that. So this is the API. New session, yeah, it's pretty simple. You open sessions, you close sessions, you call functions. Pack and unpack lets you set inputs and receive outputs. And there's also some cool stuff with, you can access the variables from within the modules directly. It's kind of neat. This is their example that they ship with it, which they actually do have some really nice examples also. I didn't mention that with the benefits, but yeah, it gives you some nice examples to get started. This is the Hello World one. You just open the Python module, you pack your variables, you run the function, and then you unpack the response and close the connection. Pretty simple. And you can get it on VIPM. LabVIEW 2018 introduced Python functions. Was anybody else excited about this? Because I was pretty stoked. Cool.
So,
one question.
Yeah.
Is there anything on the previous toolkit? Is there anything on the previous toolkit that is not implemented with the new node?
That is not implemented, sorry?
Like, so there's a new Python node. Is there anything on the toolkit that you cannot do with the Python node? So basically, why would you still use the toolkit on 2018 since now it's you have this node?
Yeah, I'm going to mention that kind of thing in a minute. There are some things. Thanks for prompting this discussion.
I also have a question on
Yeah.
the previous slide. Sorry, okay then, not that one here. Which stage of that is the bit that takes the time? You know, you said it takes a long time to load.
The first one, new
so
with the plus.
Okay.
Yeah, it's when you first open the connection. So what I would say is, like, in your init method or something of your application, initialize all of the Python modules that you want to talk to. At least that's what I would do. And then just cache that reference that it has there and keep that throughout your application and use it every time you call the function, and then on shutdown, close the reference. So yeah, back to the LabVIEW 2018 Python functions. They're native, so yeah, why would you want to buy something extra when you can just include it in there? They're pretty easy to use. It's a pretty simple API. I'll show you in a second. It's dead simple. And in my experience, it was the fastest method of communicating with Python. It also doesn't take nearly as long to open the connection. Oh, sorry, here, leave it up for a second if anyone wants to. I'm also being the fastest method. So the error handling I found was kind of minimal. At least what I saw was that there was some kind of not very descriptive errors that I got when I was testing it that were really difficult to debug, that when I would run the same function in the integration toolkit. I would run the same function just straight in Python. I would run it from the command line. This error never showed up. It would only show up when I used this one and I have no idea what I was doing wrong. I still don't know what I was doing wrong. Because it's really new and there's not a ton of documentation, so or on debugging, which I'm really hoping will improve over time, and I'm hoping that as we all use it more and ask more questions on the forums, then we can get more information on it. So yeah, I had a hard time debugging it, a large part because I had no idea what that error meant. And I also had some issues linking it with packages.
Is that a quick question? So if I'm comparing the node with the toolkit, effectively, then if I want to have that clean functionality where you create a connection, you pack, you send variables, and you unpack, I'm going to have to go build my VIs around the existing node that gets shipped. Is that correct?
To have the pack and unpack?
Well, yeah, because I don't want to have a bunch of Python nodes, one node after the next node. I'm probably going to take those Python nodes, wrap them in a VI, create my own API around it. So then it's incumbent upon me to write that API to do some common functionality. Is that correct?
So each node is calling a function. So if you want to call multiple functions in one API call for your Python class that you're doing, then like maybe you want to set directories like your working directory, and you'll have to do that separately, then yeah, you might have to wrap multiple Python node calls in one API call. I'm not sure if that is your question.
Yeah, I'm completely ignorant on the Python thing, so I'm speaking from someone who hasn't done it yet, but I'm looking at what I get out of the box from the toolkit. It looks like I have some very reusable VIs that are very simple to use, and I can get up and running really quickly, whereas I almost, if I'm going to extensively use the node, I'm going to have to create kind of my own my own API, my own library around the node to make it really effective for my team of developers.
I think especially if you're usually calling the same function, that's true, because then you're going to want to have the way that the node is set up, and maybe I'll show you in a sec here on this slide. You have to specify the return data type and which function it is. It kind of looks like a DLL. So you can do all the pack and unpack. It's all within that node because it's like a DLL sort of. But yeah, if you want to have it always be the same function that's always taking the same inputs and outputs, then you would have to wrap it in an API method. And in my demo, I definitely wrapped it in a class. So yeah, I also had some difficulties with packages. So it seems like there's maybe I was using it wrong. I don't really know. But there were some kinks that I found. And another weird thing, the working directory is not the module path. So in the nthought toolkit, and to me this is logical, if I'm running a module, I think that the working directory would make sense to be the module path because you might have relative paths in the module. But for this one, the working directory is like your default system directory somewhere. And so you need to change directory first with the Python node, and then you can call it in the node and have it be in the working directory where your module is. So I thought that was kind of weird because I definitely use relative paths in my Python modules, and I thought that made it kind of clunky. And so some notes, you need to use Python 64-bit. You can't use Python 64-bit if you're using LabVIEW 32-bit. 32-bit applications can only launch other 32-bit, so it has to be Python 32-bit. And for this one, it's not NumPy arrays, but they're lists that LabVIEW arrays are converted to. So if that means anything to you, if you understood what I was trying to explain before, that happens.
Hi, sorry. So on that last slide, you said LabVIEW will only launch 32-bit Python if you're in 32-bit LabVIEW.
Yeah.
Is that different for the toolkit?
I would assume so. I don't know. I didn't test it. But I think it works differently. Because I know that I'm pretty sure under the hood it communicates via a local TCP server, and so I don't think that, and versus the node, I think under the hood, and maybe somebody knows this and can correct me if I'm wrong, but I think it's directly accessing like the Python, like DLL way. So I think that it might be able to, but I've never tested it, so take that with a grain of salt. So yeah, the API is pretty simple. You open a session, you have a Python node, which you saw a second ago is like a DLL, and then you close the Python session. So you tell it what version of Python you want it to use, you tell it the path to your module, and then you have to put your inputs and return data types, and it'll give you your output. And afterwards, you close the connection. One weird thing that I will note and also comment on that might also be a benefit of the Endthought toolkit, and maybe somebody can also answer this question better than I was able to figure out. What do you do if a function has multiple outputs? From what I saw, there was no way to specify multiple return data types, and sometimes functions do have multiple outputs. So I couldn't figure out what happens if you do that. So I don't know if that's handled. Maybe someone who hears this presentation one day will write me an email and tell me.
So that output could be any data type, but
Yeah.
only one output.
Yeah. Yeah, I think clusters are converted to Python objects. Yeah.
That will be short anyway. Does it have RT support?
So the question is it have RT support? Can you call it from RT?
Yeah, can you run it on compact RIA?
I'm not positive. I don't actually know. Does anybody know the answer to that? Okay, we'll have to find that out.
Also, another question. On the block diagram there, the output is a string data type. What if your function in Python has a numeric output?
Yeah.
Do you have to parse that string then?
No. That input that's called return data type is the data type of what you want the output
God,
to be.
sorry, I missed that.
No, but that's a good question. I bet a lot of people were wondering that. Yeah, so you can put cluster to return data type and it'll output that cluster and so on. All good? So you also could be really creative and make a Python command server yourself. You could make it a TCP server, which Python is great at implementing. You could make an HTTP server and use a RESTful API to communicate with Python. I mean, there's really no shortage of options. You could tailor it to exactly what you want, but it would take a lot of work probably. But you could do it. There's really no shortage of options. There's other toolkits out there too. I wanted to give a shout out to LabVIEW, although I don't have time to talk about it because it gives really nice execution control. If you're looking for that, check it out. So, LabVIEW is great at hardware and as a system controller, but we should also utilize tools that are already made in Python. There's a lot of ways to do it, and it's not terribly difficult, but will take a bit of time to integrate. But I recommend it, and it's fun. So what's next? How am I doing on time?
20 minutes.
Cool.
Do the timer just
Oh, cool.
We should jump to point that out before she started.
They thought of everything. So we're going to talk about when is JavaScript really doing a good job, and then we're going to talk about how to show that LabVIEW data from your JavaScript app. And then I'm going to do that fun demo where some of you guys are going to come up here with me. Okay, I'm going to have strong opinions. You don't have to agree with me. That's okay. But I really don't think that LabVIEW makes very good user interfaces. For 95% of the applications that I do, I totally use LabVIEW for user interfaces, so I'm not saying don't do it. I do it all the time. But there's a lot of limitations. I don't think that they're very modern. The NXG controls that they made for LabVIEW 2018 are pretty cool, and they're a lot more modern than anything we've seen in a long time. They're a lot more like the flat controls, but they're still, I think, lacking compared to a lot of other things that are available in toolkits for other languages, like, for example, JavaScript.
Especially resizing.
Yeah! Yeah, it's not SVG, so resizing things, a lot of times it's pixelated. It depends on the control. Some controls can resize, okay, like, but most of them, no. They're also not responsive. Responsiveness of a UI is its ability to adjust to different screen resolutions and screen sizes. So if I look at something on my phone, if I want to look at my LabVIEW application, it's going to look all weird. And if like Tom has full HD, but Sue has like 760p or whatever, like super small, then it's going to look really different. And you might have things cut off. You can use splitter bars, you can use subpanels, you can fit objects to pane. There's tricks that you can do, and we should be doing them because it's good. It's a good practice in my opinion, but it's never going to be completely responsive. It's not going to be like when you look at your phone on an app that's really well made. You're not going to be able to get that. Also a big one that I've spent a lot of time fighting with is that LabVIEW interfaces don't natively respond to most touch interactions. So swiping, pinching, zooming, like, scrolling like this. We're also used to that. This is part of our daily lives now. We all have smartphones. But for some reason, it's not natively supported in LabVIEW. I think it should just be in the event structure. You have like a scroll, and it'll handle it. But it's not there. So why would we want to use JavaScript? It's really optimized for UI. This is the combination of JavaScript with CSS and HTML. That's what it's made for. It's 100% optimized for it. You get that responsiveness, and you get those touch interactions. Touch interactions you get for free. Responsiveness, you don't quite get for free, but it's not that difficult to implement, and there's a lot of good toolkits out there that help you with it, like Bootstrap. So, not that hard. And you can always do like media queries to make it fit on your phone, and even if you can't fully do it natively. And so it's pretty easy. So probably most applications that you're gonna use, you're not going to need this. But you will have occasionally maybe an application where you really need that tight-looking UI and you really need it to be beautiful, and you want to look at it on your phone when you're at home. Like, you can definitely do that, but you probably will want to use JavaScript for it. So how will you do that? The most obvious way to me is to use an HTTP RESTful API. Does everybody know what that is? No, okay. That's kind of like a whole talk in and of itself. So I'm just gonna really briefly go over a couple things. It's sort of it defines an architecture for a type of protocol or for a type of communication exchange that will happen over HTTP protocol. So it usually uses these particular methods to interact with data that's hosted on a server. So let's say you have an image hosted on a server. You can get the image and it'll read the data. You can post another image and it'll insert data there. You can put an image and it'll replace the image that they already have. And you can delete and it'll delete the image. You might have protections on your server that don't let them delete the image or something, but those are the types of interactions that are allowed in an HTTP RESTful API. And there's a lot of resources out there if you're curious to read more about it. But it's pretty useful to use when you're communicating from a web client to a server. And it's good if you have relatively infrequent exchange of data. So I wouldn't use a RESTful API if I want to stream a video. LabVIEW is pretty cool in that you can create an HTTP web service natively in LabVIEW, and it's not that hard. You just go to the project and you say new web service. I think I can show this little video of it. So this is a really simple web server example. I'm reading an image from a file somewhere there. Then I'm, first reading an image from I should fast forward this. It's just going to read test1 as a JPEG. It returns it as LabVIEW image data. Cool, yeah. And then I'm setting it to a functional global variable. That's because I want to get the image from within the web service without having to pass in a class reference or anything like that. So I can still get that image data. That's for debug, just to see the image. I just made a thing that lets you open the browser in there because when you're hosting it, you can just open the browser and you type in the address of your HTTP resource, and it'll get it and display it. So yeah, to start the web service, this is the resource, getting it. So there's some methods in the LabVIEW web service palette that come with it. Things like you can tell the MIME type, so you're telling the caller, the client, what is the type of the data that I'm going to send back to you. This is saying that it's the image PNG. This is a weird thing that gets around the single origin policy that happens with browsers, basically where it doesn't let you access data from a different domain. I'm not sure if it's always necessary, but we found it was in our working with it, so you might have to be aware of that. You have to set a header, and when it's doing it, setting the header called access control allow origin to star, so it's allowing origin access control from anywhere. And then we're just getting the image from the functional global and sending it as a response, which that passed. But yeah, thanks. Web service, it allows you to edit the URL of your resources, and it shows it there. And you can also change the output type. So you can set it to be a text output that you can make XML or JSON, or you can stream it. Yeah, so if we run it, which we just right-click, and hopefully I'm going to do that soon. Yeah, you right-click the image service and you say start, and then it runs it, and then there's the cute picture of a baby. And if you open the resource in the browser, then you can go to it. And there's also ways, if you get your IP address, you can access it other places, so it wouldn't be localhost. Moving on. Oops. So you could also use LabVIEW as the client with JKI, HTTP, REST, and JSON libraries. Those are my favorite tools if you want to call like Google Sheets API or Google Maps API from within your LabVIEW application. You can totally do that. Quick shout out. Try it. You could also try WebSockets. I'm going to go really quickly through here. You can find the presentation and play with this later because I want to get to the demo. So yeah, you can use WebSockets, which are basically opening a TCP connection with listeners. So the client's always listening to events from the server and vice versa. It basically opens up a connection and you can very quickly exchange data with low latency. So for that streaming of a video, probably want to use WebSocket. Shout out to Media Mongrels. They have their LabVIEW WebSockets API, which as far as I could tell was kind of the main way of doing it from within LabVIEW. I'm not going to talk too much about how to use it, but you guys can look it up. Brief recap. LabVIEW is great as a hardware and system controller. We should use stuff from Python. You can call Python from LabVIEW. JavaScript, HTML, and CSS are great for UIs, and you can serve your LabVIEW application data to be used in a JavaScript web UI. Okay, demo time. Woo! I hope it works. That'll be fun. So this is kind of my system architecture. I've got a camera, which you can connect to. You can disconnect from it. You can get whether it's connected. You can start an acquisition or stop an acquisition. You can grab. You cannot snap anymore because I didn't need it. So my camera only grabs. And then I have two child classes of that because it's a hardware abstraction layer. Sometimes when I was testing, I didn't have a physical camera, so I made a simulated one. Otherwise, it's using an iMac DX camera. Other side, we have a facial detection class, which is calling the Python integration toolkit for LabVIEW, which is running an image classification module, which is using OpenCV to do some machine learning with HAR cascades, if that means anything to you, to do facial recognition. And then we have a system controller, which is combining the two things, the camera and the facial detection algorithm, and it allows us to get an image and get a buffer length. So we have a buffer of images that we'll collect. So this is just going to run all the time when it's on. It'll collect images from my webcam. It'll store them in a buffer of a particular length, which is I have configured to 10. And then on the HTTP server, we can get that image and we can get that image buffer length. And that's going to be shown with the image in a JavaScript user interface. Does that make sense? Cool. Here I am testing it. So this is my code in LabVIEW. I'm starting my web service here. This is from when I ran it before. It'll turn on in a sec. But can I get volunteers now? Yeah. Yeah. Anybody else? Come on, at least one more person. Yeah, Fabi. Cool. Oh yeah, me too. Yeah, yeah. Oh God. So come here, please.
I wouldn't call him God.
Close though, right? Pretty close. Can I use this?
I do seem to have this field around me where computers that don't work for my customers only work when I'm present, so I think maybe that's...
Good, yeah. Come closer, please.
Okay. Oh, there it is.
Okay, maybe step back a little bit. Oh, look, there's his face. So this is just the LabVIEW side. We're running the LabVIEW camera. We're doing the Python facial detection algorithm. Maybe Fab can come join and we can see if we can find both your faces at the same time. Cool.
Stand right
Okay, I know, one more person. Yeah, but there you go. Let's see. Okay, cool. We found 3 faces.
Put my glasses on, see if it fools it.
Yeah, good question.
No?
True engineer.
Still found
But it got rid of his face.
squeezed me out.
Okay.
No, your glasses are.
Hey, found me.
Now let's see if we can run it, stay there. Let's see if we can run it from the JavaScript server. I hope my IP address didn't change. Takes a minute to serve up.
So what are you doing right now?
Right now I'm running the JavaScript server,
Okay.
and that's going to launch the JavaScript application. And so that's going to show us, okay, it worked, you guys. So this is our application. It's nice. If I could show you my phone on here, I could show you that I can also connect on my phone to this and show it at the same time. I can pick my favorite images. I can swipe through it. Like, this is just lovely.
At least she didn't my bald spot.
And we can show our favorite ones down here. If I'm going to show you some responsiveness. So I can show that I can scroll to the side and stuff, and I can view it on different sized applications, and that still works. It's pretty nice, and I can also download stuff, but this is just kind of for fun. So we're going to download that picture just as a memento. But yeah.
That's all right. That's cool.
Yeah. Okay, cool. Oh, wow, I even have time left. I had to cut down a lot of material because I was like, there's not going to be enough time. Every time I practiced it, I was like 45 minutes already, and I hadn't even done the demo. Yeah, so that's it, I think. Yeah, any questions? Lots of them. Cool. Yeah.
So you use JavaScript to develop the user interface.
True.
How much work is that with respect to what it would have taken for you to try and achieve that in LabVIEW?
So I didn't write the user interface, Danny. I worked with a JavaScript developer who made it. And it was not very difficult for him because he's a JavaScript developer. He was like, oh, this is super easy, and he did it in the weekend. And it was like mostly one day. But I have done some JavaScript UIs, and I have spent some time learning it for a customer project a few years ago. And I thought it was really fun and really interesting to get started with. It had a little bit of a learning curve, but I didn't think it was terribly difficult. So I don't know. I think it's worth doing if you want to, but I don't think it has a huge barrier to entry. Does that answer your question?
Yes, thank you.
With the Python integration, the different methods you showed, do any of them work with virtual environments, or have you tried that at all?
Yeah, like a virtual machine?
No, so with Python you got virtual environments.
Oh, I don't know what that is.
Oh, sorry. No, that's fine.
Okay.
Yeah, so you can basically set up different environments for Python, so you effectively use certain Python modules or libraries in a particular environment.
Oh, okay. I'm not sure. That's a good question. I never saw anything that referenced it on an API or any documentation, so I'm not sure.
Yeah, it was just something I was testing around. One of the other tools NI tools I use is DevStand, and they've got a new kind of step for Python integration as well, and that's kind of supports virtual environments.
It does?
Yeah.
Cool. Well, then it might. I don't know. Yeah. We should look into it. That's a good question.
In that example, what exactly was LabVIEW's role? What was it doing? Was it just telling everything else what to do, or was it actually doing something?
LabVIEW is everything in pink, or I'm sorry, yellow. So it's the camera, it's calling the facial detection algorithm, it's being a system controller that puts it all together, and it's being the web server.
But it's not doing any of the actual work. That's all being done by the...
The algorithm is all being done by Python for the facial detection. Yeah, LabVIEW doesn't do any facial detection. It just says call Python. You want to see the code? Really brave, right? You don't have to like it.
This could be the 3 minutes that ruined your career.
Okay, here's our process. It's a JKI state machine. This is using JKI state machine objects. I'm connecting to the camera, all fun camera stuff in here. Facial recognition. So basically, we've acquired the image. I'm doing some fun stuff with iMac to make copies of it, so I'm not always working on the same reference that I'm acquiring on. So I have a buffer of references that I'm always acting on. And then I find the faces, so I'm calling, this is my image detection class find faces method, which under the hood is calling this, which is call Python image function. So in my startup, I have cached my Python integration toolkit session reference. This is getting my Python session. This is calling my Python function. This is packing the image data. The reason I left it flexible for the function was because I was trying to do also eye detection, and I never could get the training set to detect it really accurately, so I just went with facial detection, because that worked. And this is a demo, so it doesn't matter. Yeah, and then it passes in and it's just calling it from there. So, and then I do some conversion. So when I call the facial detection from iMac, I'm doing some conversion from an iMac image to a Python image. So yeah, I'm just changing the color image to an array and then flattening that array. And then this is just the way that the Python module is expecting to receive the array data.
So it's a series of images rather than a video?
Yeah. I have it configurable for how frequently you want to take the images. So the way that I have it set up, the web resource, it automatically runs this launcher startup VI when the web resource, or when the web server starts. I started to tell you how to explain it, but then I stopped, on the front panel. And it has a configuration input. So I have what's my acquisition rate. So right now it's gonna it's going to acquire 10 images in the image buffer, which I don't think you can read that because it's super small. And it's going to do that every 2,500 milliseconds. So that was why I was kind of like slowly just taking pictures. But it can acquire and run the algorithm a bit faster than that. And I don't remember what exactly the numbers were, but
What is the limiting factor?
it was how fast my algorithm ran in Python.
Oh, so Python was a limiting factor.
Yeah.
Damn it.
But it was pretty fast. It was definitely on the order of milliseconds for how fast I can do it. I'm doing 3, but it depends on your image size. So it was like 320 by whatever the other dimension is, 280, I think. And I think it would run in like 300 milliseconds to do the algorithm. Yeah. Yeah.
Hi. Just wanted to add a little tiny thing to your awesome presentation to do with the JavaScript side, because if anyone's sort of appetite is whetted now for JavaScript, I noticed there you used, for example, the Node package manager in JavaScript to just deal with a few simple sort of launching of the code and stuff. But if you're interested in creating actual compiled executables for various operating systems that actually contain just JavaScript code, there is a Node package called electron.js, which really simplifies the creation of user interfaces and also interaction with actual resources on your PC, which JavaScript normally doesn't do. And that would be another method of creating a front end that doesn't actually require a web server.
Very cool.
Yeah.
What was it called? Can you repeat that?
Electron.js. Electron.
Electron. Oh, yeah.
Yeah.
Very cool. Also, if anybody's appetite is whetted and you want to get started with JavaScript, okay, we're time's up, but check out React. There's like a Git React create app thing. You can ask me, I'll tell you about it. It's cool to get started.
And just one quick question as well. Going back to the Python node, did you try inputting and outputting all of the Python data types into LabVIEW? Because there's a few that I don't think there are a direct conversion into LabVIEW data types, like tuples and ranges. Is there documentation on how to pass those in and out?
I'm not sure if there is documentation on tuples or any of those things. I didn't try any of them. I didn't have any functions that used them. So that's a good question. I don't have an answer for it. Okay. Cool, guys. Thanks.